Hi guys, Utkarsh this side. Welcome to What I Learned in a Day episode 2. So today I learned a workaround of how to create a URDF of this robot and export it to ROS. So one of the ways to do it is to go to the utilities and go to the add-ins, scripts and use this one, Fusion URDF Exporter ROS2. So this will automatically ask you a few questions, and based on that, which version you are using of Gazebo and all those things, it will create a URDF for you and export the STL files as well. But most of the time this doesn't work because it requires very strict configurations in the component settings here, like you have to have a single component or a single body inside each component and all those things, so which is a quite difficult task to follow and do. So I have come up with a workaround here of doing the same thing. So in the workaround, what I do is that right now all the components are separate, wheels are separate, the shaft is separate, the caster wheels are separate. The first thing I'll do is break the link of whatever components you have imported from GrabCAD. You just go to the component and break link so that you can modify the components in the file itself, or else you won't be able to do that. So I've broken the link. Now what I'll do is I'll go here and select this as the mainframe, and I'll combine the other components with it. So I'll combine this sheet with it, I'll combine this guide rail with it, this shaft with it, this motor mount, similarly for this one. So I have combined these components, which are rigid components and don't require any movement. In ROS, whatever links we require, whatever TFs we require separately, I have not combined them. Like caster wheel TF we require separately, wheels TF revolute joint we require separately, LiDAR and camera. But the chassis can be a single frame, which we call base link. So I'll do new components and keep tools. So as you can see now that this entire component has become one, I can hide that and bring it back. So this will be our chassis or base link, and these are the wheels, which will be separate links of type revolute, and these are caster wheels. We'll keep it as fixed only. This is the LiDAR link and this is the camera link. So what I'll do is export all of these individually. So before that, you just keep in mind that whenever you press home, this is the x-axis of ROS and this is the z-axis. So your board should keep facing the x-axis only. So, and the other thing is that your board should be like this, like it should align with the x-axis or z-axis 0. So this you do. If it's not aligning, you just move it up like this. So select all the components and move it so that it aligns to this red line. Then we can simply export all the components one by one. So we will just hide the wheels, camera, LiDAR, etc., and we will export this as a single component. This is a single component. We'll export this. So just go to File, click on Export, give the name which you want to export. I'll export it as base link and select the place where you want to store this and select STL and then click on Export. So this will get exported. Okay, so here export complete. So this base link got exported. Now what I'll do, I'll hide the base link and export this wheel. So I guess this is the caster right wheel. Yeah, so I'll go to export, I'll name it caster right and click on export. Caster right, click on export, it will export. Similarly, I'll repeat the process for left as well. Export. I'll do the same for the LiDAR. Once again, I'll do the same for the camera. Good. And I'll repeat the same process for the wheel. So this is the left wheel. And I'll repeat the same for right wheel. So the advantage of exporting it like this is that the position of each component is saved. If like you import the camera in ROS, the camera will come at this position only. So you don't need to manually adjust the position, although you need to manually adjust the position of the joints. So for that, the next step in the workaround is that you note the position of the joints manually. So what you do is, so this is a workaround, so this is a bit complex, but it works. So I'll go to point and center of circle. I'll click on this circle. So you can see a point has appeared at this place here. Here there is a point. Okay, there are the coordinates of this point. So this is the x coordinate, y coordinate and z coordinate. So note down this, that right joint coordinates is this. You just have to move this joint a little backwards. Similarly, note down the coordinate of this. Construct point and circle, click on this. Okay, note down the coordinate of this. It will be same, just the y coordinate will change and become negative. And similarly, note down the coordinate for this as well, LiDAR. Select this, okay. We'll get to know the coordinate of the LiDAR as well. Repeat the same for the camera and repeat the same for the caster wheels. And select this. So now note down the each individual coordinates and keep it. And now we will import these files to ROS. So So here I have attached all the STL files and I'm mailing it to myself, and in Linux I'll download all these STL files. So now we have switched to Linux. Now we will go to Chrome, open our Gmail and download all the STL files. Click on download all attachments. So it will download all the files as a zip file. Once you have downloaded all the files, navigate to where your files have been downloaded and unzip all of them. So here we have downloaded all the STL files of our robot successfully, and now we will import these in ROS. For that, I'll see you in the next episode. Thanks for watching and all set.